In trigonometry, we study triangles, more precisely about relationship between the lengths of the sides and angles. Before we jump into triangles, we will talk about angles. Angle was the next important measurement system discovered after length. Angle helped in understanding and quantifying rotation motion, like this rotating arrow of trigonometry, whereas length was used to quantify translation motion.
But why angles? Couldn't we just use length for rotation? Like just measure the length of arc subtended by this? What you call rotating arrow of trigonometry to quantify rotation?
It was the first idea, but then it was found that this arc length depended on the length of the arrow, or how far is the point from the center.
You mean the radius?
Yes, arc length is proportional to the radius.
So why don't we take the ratio of arc length by radius? That can be a measuring system.
You cannot say that until you know that the arc length is directly proportional to radius and not radius square or anything else. But in this case, you are right. This system of measurement is called Radian system. Because we know circumference is 2 pi r, here itself we can say that the arc of a complete circle is proportional to radius and the ratio comes out to be 2 pi. This was taken as a measurement of a complete rotational angle and its half became pi and so on. Another more familiar unit we use is degrees, where a complete circle is said to be 360 degrees and each unit becomes 1 by 360 of a complete circle. Next, we will try to quantify the position and orientation of rotating arrow of trigonometry by superimposing our Cartesian coordinate system on this arrow of trigonometry. For the sake of simplicity, we take the initial and original position of the arrow to be along positive x-axis and call this as position 0. As the arrow moves anti-clockwise, that is towards positive y-axis, the new position takes positive value, and when it moves clockwise, that is towards negative y, its position becomes negative. Now before we move forward, while we are using Cartesian coordinate, we will talk about independent axis and what's its significance. We know that x and y are at right angle to each other. When two directions are at 90 degrees to each other, we say that they are independent.
Why?
Let's bring back our arrow. To reach from tail to head of this arrow, you have to travel along both x and y axis. Let's look at x component of this arrow. When the arrow is at right angle to x axis, that is along y direction, it has 0x component. Similarly, when it is along x-axis, the y component becomes 0.
Can you explain the concept of components? I'm still not clear.
Let's start with one dimension. If I give you a point, how will you find its position?
I'll start from origin and the distance it takes considering the direction I'm moving in. We will get the position of the point.
Now, if you have this point in 2 dimensions, how will you reach it? If I say you can only move in either x or y direction.
Don't expect me to know everything.
See, you first move in x direction and then move in y direction. Simple. And these two lengths become our x and y components.
Why didn't I move in y direction first?
Of course you can do that and the result will be same.